Okay, so Penny Boston is our next speaker, and she'll be talking about seeking Earth-derived biosignatures on the moon. Okay, Penny, are you there?
Can you hear me?
Yeah, maybe speak up just a little bit.
Okay, I'll scream into my phone. How's that?
That's good. That's good.
Great. Okay. So I wanted to just quickly present the very essence of an idea that Greg Schmidt and I have been working on for a couple of years, on and off. And this has to do with really the astrobiological value of lunar materials, as we may be able to recover them with our new emphasis on lunar missions. Next slide, please. So the science case has been laid out by others, and but not much work has been done on it for the last decade. The major aspects are that we certainly know that major impacts over Earth's history can loft material out of the Earth's gravity well, and some of that material will have arrived on the moon. Several folks, Armstrong, Crawford, and their colleagues have talked about this in a number of papers. Some ejecta that happens with these events may contain biomolecular and possibly structural paleontological information. And this could represent a lot of the Earth epochs during those that have a very poor Earth rock record. For example, the Great Unconformity and various other epochs where depositional preservation of materials has been very poor. And so on Earth, when we have a collection of material that is together in a deposit, we call it a death assemblage or a thanatocynosis, and we are positing that the moon is essentially a big basket for receiving early Earth and later Earth materials of astrobiological significance. So the questions boil down to, would such materials be delivered in sufficient quantity that we could find them? The classic needle in a haystack problem. Would they be delivered in predictable locations? Armstrong has a paper looking at a high degree of impact of such materials landing in the polar regions, so that at least narrows it down somewhat. And then obviously the fact that we've got enhanced lunar access makes us want to spread the word, because we're not currently contemplating a dedicated mission to go look for these things, but these materials could show up in a lot of the material that's going to be processed for answering other scientific questions. One of the most important aspects is that previously preserved or fossilized material would be the most likely to survive the impact and subsequent space weathering, because it will already have undergone diagenesis, potentially mineralogical replacement, and make it tougher. And but it's still worth looking for gooey stuff, that is Earth-derived organic life evidence as well. So the structural biosignatures may be very rare, maybe much more rare than looking for material, but they are less confounded by organic noise, because we know that we live in an organic chemistry rich galaxy and solar system. And potentially they may be more resistant to lunar weathering. We will see. Next slide, please. So there have been a number of plausibility observations and experiments and even models done that bear on this general topic. One of the things that galvanized my interest in it, again, was the Bellucci paper of last year that David Kring brought to my attention, and this claim of Earth-derived zircons in an Apollo classic sample. There's a previous paper that looks at non-lunar material, possibly a planetary origin in a lunar meteorite. And so this issue that was worked over by Burchell and company in 2010, it's time for a new look at this. Organics have been impacted into things. There's several papers that show their detectable and interpretable survival. Then there's microorganism survival under impact, done primarily for planetary protection and other purposes, but still are apropos to this. And then after impact, plant seeds at least leave organic materials behind. And we certainly know that there are many organisms on Earth that survive space conditions. Now to my last slide, please. So all we're suggesting is that for big splatteromas on Earth, valuable material may have been lofted to the moon that is worth looking for. We're not really expecting to find big chunks of dinosaurs, but the vast array of micro fossils that Earth material contains may be there in places that we can look for. We think that it's very important. This could be perfect for a citizen science project, and that the rest of this slide simply details places where we think would be very good to look at, and that there's a high probability of deposition that overlaps with sites that are relatively protected from space weathering, like below the regolith, in caves, in fractures, and et cetera. Done. Thanks.
Thank you, Penny.